seminar for his thesis, and it should just be an outstanding seminar. As many of you know, David came to us from an undergrad at Berkeley, and when he got here, he was really interested in trying to understand the role that adaptation plays in the formation of new species. And he was interested in the ecological as well as the genetic mechanisms that can lead to the formation of new species, especially through the process of local adaptation. And as you'll see, he's really made tremendous progress on that front since being here. I'm not sure exactly what David is going to cover in this talk because he's done a ton of different projects, and he probably won't have time to talk about them all today. But his work has really also brought in a lot of new approaches to the lab. We're now doing ionomics, of all things, and studying things like salt tolerance that we'd never studied before. He also has really, as you'll see, there's a large role of flowering time in the work that he's done, and that has now been it's now a big part of the work we're doing in the lab. But beyond his own immediate research and the work that he's helped foster in the lab, he's also been a really important force in bringing together people from other labs working on Mimulus. He organized single-handedly this Mimulus wiki site for Mimulus, a community of researchers, and he also has tremendously added to our collection of Mimulus populations that he's collected all over Western North America, and these are going to be an invaluable resource in going into the future. So I'm really glad that he's finishing up, and he's done a great job. I'm really sad that he's leaving, but he's going on to an absolutely outstanding postdoc with Tom Younger at University of Texas, Austin, working on biofuels, switchgrass, and adaptation in that system. It's going to be really exciting work. But here today, we're here to hear about his thesis work, and so David Lowry, take it away.
Okay, thanks, John. All right, wow, great. Thank you all for coming out. I appreciate it very much. It's good to see you, and wow, this is amazing to have like the final talk in this room. I feel like I've given a lot of talk in this room. To have it be the last one, that's wild. So this is the title of my talk, which I put on the seminar. But this is kind of more of what I feel like the talk may become. And I've been having an ongoing debate with John all week on this. And so I'd love to hear you guys chime in. Like, even though I'm finishing up my dissertation right now, the ideas are always still developing. So it's always great to get more feedback from people on these things. So because it's a dissertation seminar, and I'm going to get a little more scholarly, so I'm going to like flash back to Plato and Aristotle to start with everything. And Plato and Aristotle had a lot of debates with each other. Plato was into forms. Aristotle was into essences. But they both could agree on one thing, and that was the mutability of species. If you have a bluebird and it crosses with a bluebird, you get more bluebirds. And you always get this every single time. And for many, many organisms, you see this phenomenon. But Aristotle encountered one organism that really threw off this whole paradigm, and that was the mule. He could see there was a horse and a donkey, and when they mated, you would get mules, and the mules were sterile. And so he's like, what is this mule thing? It's like, is it a separate species from these other things? It didn't really work out with his paradigm. So this whole idea of immutability of species and whatnot, the mules got forgotten. It all got integrated together with Christianity through the Byzantine Empire and all kinds of different things through the years. And then about 2,000 years later, some guys sporting retro-Hellenistic styles, looking kind of like Plato and Aristotle, came along, and they said, well, we got a solution to this problem. And it's simply, you have your show horse and your donkey with their beautiful smiles, and instead of there just being a conflict, we can just think about back in time. There was this ancient proto-horse-donkey thing, and at one point in time, they split and became separate species, or close to separate species. But even though they had sort of pointed this out and started to change biology forever, we still didn't have an idea of what happened down here in this area where they were splitting off and becoming separate species. And to this day, we still have a big debate over this issue. So after this period of time, even though Darwin pretty much threw out Lamarckianism and moved on with natural selection as being underlying evolution, there were still persistent Lamarckism in plant biology especially. And one of the